Okay, today we're going to work on tree diagrams. So in many cases, there is more than one action or choice, which results in several outcomes. Tree diagrams are a useful tool to organize and show all the possible outcomes. Okay, so we're going to start with the spinner below is spun twice. So let's see, right? If we are spinning, we have the possibility of A, B, or C, right? And then, so this is the first time. And then the second time, A, B, C, A, B, C, A, B, C. So as you can see, after the first time, we spin again. So let's say you spun B, the second time you could spin A, B, or C. So our sample space, it means like the possible outcomes, right? So our possible outcomes, we're going to use a little bracket, is either A, B, A, C, B, A, B, 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 C, C, A, C, B, C, C, right? These are all the possible outcomes for two spins. Okay, so now we do the probability, right? So if we think there's 9 possible outcomes, right? So the probability of getting B twice, so BB, is 1 out of 9. Because we have these 9 options, and this is the only one that has the probability of getting it twice. The probability of at least one A, so if we look here, this would work, this would work, this would work, this would work, and this would work. So that is 5 out of 9. And then the probability of no C, so this would work, this would work, this would work, this would work. So that's it, 4 out of 9. So it's similar to before what we were doing, except for now we have a few options, right? Because there's different branches of a tree. Okay, the popcorn stand offers buttered or unbuttered popcorn in 3 sizes, small, medium, and large. So we can do like butter, so buttered, unbuttered, and then we have size. Small, medium, large, small, medium, large. So our sample space would be, let's just do B for buttered. Buttered small, buttered medium, buttered large, unbuttered small, unbuttered medium, unbuttered large. So the probability of buttered, well, we know that there's 6 total. So the probability of buttered is going to be 3 out of 6. And we want to simplify that to 1/2, and that is 50%. Let's go back up and get the percentages for the others. So we have 1 divided by 9, so that is 0.111 or 11.1%. So 5 out of 9 is 0.555 or 55.6% because we want to round up. And this would be 0.444, 44.4%. This is 0.5. Oops. Okay. Probability of a large. So these two are large. So we have 2 over 6, which simplifies to 1/3, 33.3%. 0.33. So the line there means it's going on forever. Small with no butter. So these two are small, and this is the only one without butter. So it's 1 out of 6. And 1 out of 6. Is 0.16 with a line over it, so 16.7%. All right, you have a choice of vanilla or chocolate ice cream topped with sprinkles, peanuts, granola, or M&Ms. So we have flavor, toppings. So we're going to assume that you can only get one topping in this problem. So we have sprinkles, peanuts, granola, M&M. So we have vanilla sprinkle, whoops, let me write that. Vanilla sprinkles, vanilla peanuts, vanilla granola, vanilla M&M, chocolate sprinkles, chocolate peanuts, chocolate granola, chocolate M&M. Okay, so the probability of chocolate is going to be, so there's 8 total. Probability of chocolate is 4 out of 8. Probability of M&Ms, these two have an M&M, so it's 2 out of 8. The probability of vanilla with sprinkles, so it's just 1 out of 8. So this is equal to 1/2, 1/4, 0.5, 0.25, 0.125, 50%, 25%, 12.5%. All right, so that is tree diagrams. All right. The day of a week is chosen at random and then a coin is tossed. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, and then we have heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails, heads, tails. Our sample set: Monday heads, Monday tails, Tuesday heads, Tuesday tails, Wednesday heads, Wednesday tails, Thursday heads, Thursday tails, Friday heads, Friday tails, Saturday, Sunday. Right, so if we think about it, how many do we have? We have 7 days times 2 options. We have 14 total. Probability of tails is going to be 1/2. Probability of a day that starts with T is going to be 1, 2, 2 out of 7. Probability of Friday, and then heads. So that is going to be 1 out of 14. Because Friday, then heads is just this one. So this would be 0.5. 0.286. I'm going to do 3 decimals as a general rule. 0.071. So 50%, 28.6%, 7.1%. All right. The spinner below is spun, and then a letter from the word math is chosen at random. So we're going to do trapezoid, parallelogram, rectangle, rhombus, square, and then MATH. Remember, you can always try these problems, pause the video, and then see if you get it right, or you could work along with me. So we have 5 times 4 equals 20 possible. I'm not going to list it out because it's going to take a while. Okay, probability of the letter M. So, okay, actually I will write it out. No, I'm not. Okay. Probably the letter M is 1/4, right? Because if we think about it, we're going to have 1, 2, 3, 4, 5. 5 out of 20 are going to have the M, which turns into 1/4. You can also think, since it doesn't matter about the first part, it doesn't care about the spinner or the shape, it's just out of the second choice, the MATH, and there's 4 letters. And 1 M. So since this isn't saying anything about the spinner, we can actually just do the probability of just the M from the math. A shape with 4 congruent sides. Okay, so this one's actually tricky because you have to know the definition. So a square is this, and a rhombus is this, and these are all the same. So both of these have 4 congruent sides, so it's going to be 2 out of 5 shapes, so 40%. A trapezoid, then not an A. So we have trapezoid and then not an A, so that means that we have 3 out of 20. So 3 out of 20 is the same as, oh, I should know this, 15. All right, last example. A standard die is rolled and then the spinner is spun below. So, right, we have a standard die is 1, 2, 3, 4, 5, 6. red, blue, yellow. All right, so we have 6 numbers times 3 colors equals 18 total. So the probability of a prime number, so we have 1, 2, 3 prime numbers, so it's going to be 3 out of 6, or 1/2. Probability of red is 1/3. At least 3 and then yellow. So at least 3 would be 3, 4, 5, and 6, and then yellow. So if these all had yellow, that would be 4 out of 18. So 4 out of 18, 2 out of 9, 0.222, 22.2%. All right, hopefully that makes sense. Okay, so now we're going to do a little bit of traditional notes. So fundamental counting principle. You can use the counting principle to find the total number of outcomes. So we did this before, but now we're having the definition. So if one activity can occur in m ways and another activity can occur in n ways, then both activities can occur in m times n ways. So right, we did that before, where we are multiplying to find the total possibilities. So total number of outcomes. Okay, to leave her office, Karen can choose between 3 sets of stairs and 7 doors. How many ways can she leave her office? So 3 sets of stairs, 7 doors. So we're going to do 3 times 7. That equals 21. A sweater comes in 4 sizes and 8 colors. How many different sweaters are possible? So 4 times 8 is 32, right? Like if you were at a store, think about it. You see a sweater, 4 different sizes, 8 different colors. How many different options are there? 32. Okay, a class has 11 boys. Okay, so I'm going to go over and do all these. A card, standard deck, quarter is tossed, day of the week is chosen, 5 multiple choice questions, 2 letters, digits, 16 girls. All right, so we have 11 times 16. I don't know that off the top of my head. 176. Dinner consists of 5 appetizers, 12 entrees, and 3 desserts. So 5 times 12 times 3. So that would be 60 times 3 is 180. Right? 5 times 12 is 60. 60 times 3 is 180. Card is chosen from a standard deck. So remember, there's 52 cards in a deck, and then a die is rolled. There's 6 sides to a die. So we can do this in our head, right? So 50 times 6 is 300, and then 6 times 2 is 12. So it should be 312. Let's check. Nice. Okay. A quarter is tossed, so heads or tails. Then a letter from the word snowflake is chosen. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I don't think any of those letters are repeating. S-N-O-W-F-L-A-K-E. Nope. So there's 18 possible outcomes. A day of the week is chosen. 7. And then the spinner to the left is spun twice. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, but it's spun twice, so we're going to do it again. How many ways can someone randomly dial a 7-digit phone number? So we have digits 0 through 9, so that's 10 digits, or 10 numbers. So if we have a 7-digit number, we have 10 times 10 times 10 times 10, 4, 5, 6, 7, right? Because each of these digits could be any of these 10 numbers, 0 through 9. So we're going to do 10 times 2, 3, 4, 5, 6, 7. Or you could do 10 to the power of 7. Same thing. A quiz contains 5 multiple choice questions. Each question has 4 answers. How many ways can the questions be answered? 20. The library code uses 2 letters. So letter and then a digit. So the 2 letters, so 26 times 26 times 10. Six, 7, 60. Oh, actually I did number 9 wrong. Okay, so we have 5 multiple choice questions. And each of them can be answered 4 ways. So it's actually 4 to the power of 5. Maybe I'll make it so 4 to the power of 5. And that is equal to 1048 or 1024. Right? Because I could answer this one 4 times and this one 4 times. So if it was only 2 questions, then there'd be 16 options. Right? Once I had the 3rd question, then there's 64 options. So that's why with 5 questions, we can get up to 1,024 different ways the questions can be answered. Right? So that one tricked me. Okay, next side. Last page. Patrick is buying a new car. He can choose the body style, color, and engine type. There's 54 ways he can select a car with 3 engines, with 3 body styles and 2 engine choices. Okay, so I need another color. So we have color, body style, and engine type. So we know that this times this times this equals 54. Okay, so 3 body styles, 2 engine types, and then mystery amount of color. So we know that this is 3 times x times 2 can be written as 6x equals 54. Then we divide both sides by 6, and we see that x equals 9. Okay, at the school cafeteria you can choose 1 sandwich, 1 snack, and 1 drink. The number of drink options is equal to the number of snack options. If there are 63 ways to choose your lunch with 7 different sandwich options, how many drink options do you have? So you have sandwich, snack, drink equals 63. 7 different sandwich options. And then it says drink is equal to snack. So I'm going to use the same variable. I'm going to use x for both. So pretty much we have 7x squared equals 63. Divide both sides by 7. X squared equals 9. So we know that x equals 3. So we have 3 drink options. Okay. A coin is tossed 3 times. What is the probability of getting heads just once? So we have, right, first time, heads, tails. Second, heads, tails, heads, tails. Third, heads, tails, heads, tails, heads, tails, heads, tails. Right? So our combination is, so we should have, if you think about it, right, we should have 2 times 2 times 2 equals 8 options, and our 8 options are heads, 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 tails, heads, tails, heads, heads, tails, tails, right? I'm going down like this. Tails, heads, heads, tails, heads, tails, 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 heads, tails, 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 right? These are my 8 options. What is probably getting heads just once? So this one, and this one, and this one all have heads just once. So it's 3 out of 8. right? 3 possible options, 8, or 3 options and 8 total options, right? A month is chosen at random, then a standard die is rolled. What is the probability of giving February and then a number less than 5? Okay, so we have possible outcomes. 12 times 6 equals 72. So the probability of getting February and then a number less than 5. So we can get February 1, February 2, February 3, February 4 are all like the things that we would want. So this is 4 out of 72, which is equal to 1 over 18. We can keep these in fractions. If you want to do the decimal too for practice, you can. But as long as it's simplified, I'll accept it. Okay, there's another way to do this, so I'm going to do it over here. So if we think about it, the probability of February is 1 out of 12, and then the probability of less than 5 is 4 out of 6. So we can multiply these together times the total. So we have 72 times 1 divided by 12 times 4 divided by 6, and we get the 4 again. So that's another way of doing it. You just want to think of what you can do and what you need on top, and then your total options on the bottom. Okay, a card from the standard deck is chosen at random, then a coin is tossed. What is the probability of getting an ace and tails? So 52 times 2 equals 104 total. Winners, we'll call it favorable outcomes. Ace, tails, so that is 1. So it's like ace, tails, but sorry, there's 4 different aces. So ace of hearts, tails, ace of diamonds, tails, ace of clubs, tails, and ace of spades, tails. So 4 out of 104. That simplifies to 1 over 26. Another way we could do that is we do 104 times 1 out of 13 cards times 1/2 equals 1 over 26. Okay, a standard die is rolled 2 times. So we have 6 times 6 equals 36 possible outcomes. What is the probability it lands on 1 both times? So favorable would be a 1 and a 1. So that is 1 out of 36. Another way that we could do it is 1 out of 6 times 1 out of 6 equals 1 over 36. Actually, let me go back up here. So I said, sorry, I shouldn't have times it by total over here. So the probability of 1 divided by 12 times 4 divided by 6 is equal to this, which is the same thing as 1 over 18. So sorry, if you take the probability of one times the probability of the other, then you get it. Okay, so the answers I have are right. I just explained this one a little bit. Okay, use the spinner. Each spinner is spun once. What is the probability of getting yellow and then an even number? So probability of getting yellow is 1/5. Even number is 1/2. So it's 1/10. Another way to do it is, okay, so we have 5 times 8 equals 40 total. And then the favorable would be yellow 2, yellow 4, yellow 6, yellow 8. So 4 out of 40 equals 1 out of 10. What is the probability of getting an orange or blue and a multiple of 3? So 40 total And then the winners, so favorable is orange 3, orange 6, blue 3, blue 6, so 4 out of 40, or 1/10 again. And then the way of doing it the other way is orange or blue is a 2 out of 5 chance times multiple of 3 is 2 out of 8 chance, right? Because it's 3 and 6, so 4 out of 40 is 1/10. Okay, so now you just gotta do the practice problems, and hopefully you feel good about it.